and roll. All right, guys, so let's jump in here with me. I'm going to start off with a topic that is really near and dear to my heart, and that is what a theory is, what a scientific theory is. Because one of my biggest things that I just hate is when I hear it, or I see somebody posted on social media, or somebody says something on the news where they say, "Oh, well, that's just a theory." That is an offensive thing to a scientist, because a theory is really our best answer we have. All of science is made of theories. So let's look at this little slide here real quick and understand the difference between a law and a theory. A scientific law is going to tell you what happens. Okay, so if you have a law, that's setting up a situation where you know what's going to happen, so that then you can do science. So that every time you set up an experiment, you're not also testing the law of gravity. Because we know that if I take something, looking for something soft here, if I take an object and drop it, it's going to go down. That's the law of gravity. I'll just use my little atom here. So if I drop this little black atom, hydrogen atom, it's going to go down. Law of gravity. Okay? If I drop it, it goes down. That's not science. That's just setting it up so that you can do science. Okay, you have the law of gravity. In chemistry here, we're going to talk a lot about the law of conservation. The atoms you have to be equal to the atoms you end up with. You can't get rid of atoms, and you can't make new atoms. Theories are a little bit different. Instead of telling you what's going to happen, a theory is going to tell you why. A theory is going to explain the science behind something. It's going to tell you how something happens. A theory is based on our best evidence. A theory is not just telling you what's going to happen. A theory is telling you why, and it's our best answer. And theories can change. Theories can change if you get better answers. So let's check this out. Anybody know why the atom, the hydrogen atom, little black ball here, drops when I let it go? What does that mean? Why? Why does the ball go down when I let it go? So gravity is a force that brings two things closer together. Why? Very good. The reason I dropped this ball, the reason it goes down, the theory of gravity is that this ball is going to go down when I let it go because the Earth is humongous. The reason we stick to the Earth is because it is massive. It is huge. And that's why when we go to the moon, do we stick to the moon? Yes, but not as much. Okay? Now, that's pretty wild to think, is that me and this ball actually have a gravitational force. But why doesn't it stick to me?
You're not that big.
Very good, because I'm not that big. Now, you have to pick on me, okay? But I'm not that massive. I don't have that much mass. And so the force is negligible. The force is really, really low. Now, that's the theory of gravity. It's explaining why this drops down. But let's say that I dug a hole underneath my feet, and I discovered that there was this species of gnomes who lived underneath my feet and was holding my feet to the ground with magnets. And so I've discovered, hey, I'm not sticking to the Earth because the Earth is big. I'm sticking to the Earth because there's these little magnet gnomes that move every time I take a step. Okay, that seems silly, but if I could dig it up and prove it, guess what I would have? I would have a new theory. I would have a new theory, and it would be a better theory because I could show you the gnomes. And if I killed my gnomes, I'd go flying off into space.
Charge for it. Charge people for it.
Sure, but I mean, and you can make some money on discovering science, absolutely. But the key thing there is theory is the best answer we have. I usually don't talk about facts in science because you can always come up with a better fact. You just have to have better evidence. Okay, so but theory is the absolute best thing we have. There's another example right here. Years ago, we're talking 400 or 500 years ago, there was this idea of the phlogiston theory of burning. And what it said was, that anything that can burn contains this material called phlogiston. And during burning, the phlogiston is released into the air, and the burning stops when the object is either out of phlogiston or the surrounding air contains too much phlogiston. That kind of makes sense, right? When you set something on fire, does it burn forever? It burns until it runs out. Another way you can make it go out quicker is do what to it? You could blow it, put water on it. You cover it up. If you cover it up, now it's still, can you light, let's say I set this piece of wood on fire and then I let it burn for a second and then cover it up. What's going to happen? It's going to go out because we know why, but this thing would say that there was too much phlogiston in there, and if I open it up, can I light it back on fire? Probably. Okay? But this was the theory of burning, of why burning worked. We got better things. This was replaced by the combustion theory. Rather than phlogiston, instead, it's oxygen atoms in the air combining with carbon atoms in this, releasing energy. So we took a theory that was a pretty good theory and replaced it with a better theory because we have better evidence. That's the key thing about science, is you're constantly doing science. You're constantly replacing your theories. All right, let's look at chemistry. People have been doing chemistry before there were classes. Long before there were schools to teach you chemistry, there was chemistry. In the beginning, you have what they call practical chemistry. Practical chemistry is chemistry that just solves a problem. So let's look at some examples there. If you wanted to carry water from your water source to your house, you would need to hold your hands and try not to drop the water, or you could look over and say, well, that clay gets really hard when it gets cooked in the sun. Maybe I could shape that clay into a pot and I can carry my water. People didn't realize it, but what they were doing was they were chemically changing the clay. They were doing some chemistry, making some weapons. People realized, hey, I could fight with this rock. But then a smarter person said, if I really heat this rock up and make it long and flat, instead I have a sword. Who's going to win in the person with the rock versus the person with the sword? The person with the sword. And so people are using chemistry to come up with better weapons. People realize, if I take animal fat and I cook the animal fat and I wash my body, I won't have as many infections and I won't have as many blisters and sores, because they pretty much created the first soap. Now, wine is up here, and everybody always, man, Mr. Tyman, he gets wild. He's talking about drinking wine up here on the second day of chemistry class. But that's not really what I mean. Okay? Wine was not really, thousands of years ago, was not really something to get drunk on. Right? And this is something that a lot of us know from Sunday school, because it's something that really confused me when I did Sunday school years ago, growing up at First Baptist Church in Grifton. Because my mom and daddy told me, don't drink, no alcohol in this family, because we go to the Baptist church and we don't drink, okay? Well, it was very confusing because I went to Sunday school and we learned about Jesus. What was the first thing Jesus did?
Turn water into wine.
Yeah, he turned water into wine. And I'm like, whoa, whoa, whoa. I'm supposed to be like Jesus. Jesus was keeping the party at the wedding going. What's going on? And so as I grew up and as I understood about early practical chemistry, the wine from 2,000 years ago wasn't necessarily to get drunk on. Why would you drink wine 2,000 years ago? What happened? Well, sort of, but what happens to when you put a little bit of alcohol in your water? What do you not have to worry about being in it? Exactly. Don't have to worry about it having bacteria in it. And so 2,000 years ago, if you were drinking water at the wedding, you might get sick. If you were drinking wine, you were safe. And so this is like, we're talking wine that's like 1% alcohol. We're talking, these people were not getting drunk necessarily 2,000 years ago, but they were being safe and they weren't getting sick. So wine, some of that early practical chemistry, medicine, of course. Then you had Greek culture. Greek culture changed a lot for a lot of different things. You talk about Greek culture in social studies class as well, but the Greeks brought in, Aristotle specifically, brought in 4 elements. I know y'all watch Avatar, so you can tell me all about them, but you got earth, wind, fire, and water. Now, obviously, we know there's way more than 4 elements, but This idea that you could make everything from a limited amount of things was huge and super important for the history of chemistry. Next big leap was alchemy. Alchemists, about 500 to 1300 CE, that's in the Common Era, AD is another way to look at it. Alchemists were people who got a job with rich people. They were scientists who got a job with rich people. And if you want to get a job with a rich person, the easiest thing you can do is tell them, I can make you richer. And the easy way the alchemist told them I can make you richer is I'm going to take all of this copper and all of this tin that you have lying around your kingdom, and I'm going to turn it into gold. And let me show you this little chemical trick to prove that I'm on the path of doing it. And so for hundreds of years, every king and every lord and every duke had an alchemist working in their castle to try to be the first one to come up with this sorcerer's stone that would turn cheap stuff into gold so that they could be richer. Now, obviously, we know that they never came up with transmutation. They never came up with the ability to do that. And in our chemical reactions, this is going to be impossible. This takes nuclear reactions to be able to do. But the things that they did do are super important for the history of chemistry. Modern chemistry came from alchemy. And if you look at the word there, it says alchemists. Right in the middle of the word is CHMI, chemistry. Okay? And so what did they do for us? Well, they came up with how we do experiments. They came up with types of glassware that we do. I always think of, whenever I think of an alchemist, I think of Gargamel from the Smurfs in his laboratory with all the bubbles and everything. I mean, that was early alchemy. That was chemistry. And we learned all about things, about the elements. Even though they didn't have a periodic table, they learned about the information about the elements and then developing alloys, which is mixing different metals. So today, what are we doing in chemistry? And this was your bell ringer from yesterday. If you didn't do your bell ringer from yesterday, get on it. Just because I've already graded it doesn't mean you can't go back and do it. Everybody in here did it, but I have a bunch of people at home that missed out on their bell ringer. Go do your bell ringer, get those points every day. Do your bell ringer today as well, get those points every day. So chemistry is two things: the study of matter and how matter changes. Some different areas of chemistry. Organic chemistry is not really what we're going to be doing in this class. This is mostly inorganic chemistry, but organic chemistry is going to be specifically studying carbon because carbon reacts in a different way. Carbon is going to be what makes living things, and it's going to react a little bit differently than normal inorganic chemistry, which is what we're going to be doing in here. Biochemistry is pretty straightforward. It's the chemistry related to life cycles and living things. Physical chemistry is looking at physical properties, heating points, boiling points, melting points, freezing points, things like that. And then you can do lots of different things in chemistry. You know, chemistry is one of those classes that a lot of people kind of dread and everybody knows they have to take it. But I know a lot of friends who make a lot of money doing chemistry, and you know, you can work just across the river here in Greenville at there are two different plants that make bulletproof vest stuff and medicine right across the river. They have chemists working in there like crazy in all different types of jobs. But no matter what you do, even if you don't do something related to chemistry, the problem-solving things that we're going to be doing in this class are going to help you no matter what career you decide on. So just look at some other things, some things that chemistry does for us. Hits pretty close to home on this last one, synthetic fibers. Anybody know what synthetic fibers has to do with Grifton? Yeah, just across the creek, heading towards Kinston is DuPont. And you guys are just getting aging out, but like when I went to high school here in the 90s, everybody's grandparent or parent worked at DuPont. Grifton was the fastest growing town in the 1950s because DuPont was the largest synthetic fiber plant in the world when it was built. And so it's kind of fallen off and isn't the same thing as it once was, but they're still making those synthetic fibers there. They're still studying synthetic fibers there and taking things and pretty much making all of our clothes now, which, you know, if I was teaching this class 50 years ago, everybody sitting in front of me would have cotton or something that's natural on. guarantee you just about every one of you have some percentage of synthetic fiber in your clothes, and that has to do with, that kind of started here in Griffin with synthetic fibers. And then there's all kinds of different government things as well that regulate chemistry. Questions on the history of chemistry? We're going to start some math tomorrow. Make sure you do your virtual lab. Virtual lab, the easiest way to do it is open it up, the PhET lab, as a second tab and kind of just go back and forth answering the questions that are on the Canvas sheet. All right, if there's no other questions, I'm going to shut down the sharing thing here, guys.